Good evening, everyone. Welcome to our second session of Diabetic Retinopathy brought to you by Hexar.in. The link for today's collab notebook is shared in the message box. Please open that link. When you click on that link, you will be taken to the Diabetic Retinopathy N2 notebook. Ravi, if you could please come to the notebook. Go to the very top. Okay. Now, from this, okay, now this is the notebook that I have shared with you. I would like you to copy this notebook so that you have one copy of this shared in your drive so that you can work on that notebook. The project has officially started from today's workshop, and we will be teaching you bit by bit about the components that will go into building a diabetic retinopathy classifier, and then how can you improve on that. So it is very critical that you play with the codes and you understand what is going on and how you can improve on it. That is the main part that we are trying to uh, get from you. We will be teaching and explaining every component in you. Mm, Today's session will be focused on data exploration and data building pipelines. So for that, go to the file menu. Uh, Ravi, if you could just show in the file menu, and then click on save a copy in Drive. Save a copy in Drive. Now, what this will do is this will create a new notebook for you, and it will save you in the name of copy of diabetic retinopathy into. Once done, the first step that I want you guys to do is mount your Google Drive. And once you have mounted your Google Drive, I want you to extract the data that we have shared previously, just like the way we did in our previous workshop. So, Ravi, if you could just execute the cells with the data extraction code. So the first cell is just mounting on the Google Drive. The second cell is checking for GPU. Now here, since we are not training any network today, we only need a CPU powered system, not a GPU powered system. Google Colab provides both CPU and GPU powered systems, and you can change this by clicking into runtime. Click on runtime. And click on change runtime type. Now, once you click on that, you'll get this menu in which you have this selector which says now you'll be presented with this selector, and inside this you can select either none, GPU or TPU. Now, since we don't need GPU powered, so we'll select none. Select none, yes, and click on save. Now, once you have set up your notebook, extract the data, which is from the tar minus XDF code. And since we have already extracted our data in this notebook, you can scroll down, Ravi. Scroll down. Now, what this is doing is it is extracting the data and keeping the data into this balanced data folder. Now, here I want everyone to copy the data and then extract it and keep the extracted data in your drive. Now, after this, here we are, the first thing that we are doing is we are importing pandas library. Why we are wanting import the pandas library? Because we want to take the CSV label file and we want to create a data frame out of it. Data frame is nothing but a fancy array. It is much more advanced than what Python can provide, what a Python can provide support in its array, and it has multiple other functions which are very very helpful in data science, which is why we use pandas. We'll dive deep into pandas a bit in our later session, but for now we need to understand two functions. The first function of pandas is read CSV. What this function does is takes the path of a file and then reads that file and then creates a data frame out of it and shares that data frame with us. So here label 0 contains the data frame for class 0 labels which comes from class 0.csv file. Similarly, label 1 contains the names of class 1.csv file and so on and so forth. Now after this, in the next cell, what we are doing is we are concatenating all these labels into a single file here in this one. So what this cell is doing is it is taking all label 0, 1, 2, 3, and 4 and it is appending one at the end of the other. So we get one single file which has all the names of all the classes. Now if you explore its head, which can be found by labels.head, this is a data frame function and it shows the first five entries of our data frame. Now if you execute this label.head, you get this first five folders. But remember this, here you can see that the name is only given as a code. The extension, which is .png, if you scroll a little bit up, Ravi, if you can scroll up, upside up. Okay, now if you can see in this extracted files, all of the files have an end with .png. So we need to provide this extension also. Otherwise, you will get path error if you try to read them. Scrolling back down. Inside this, let's create a way of reading a single image and displaying a single image. So we are here creating two functions, but before that we need to import three libraries. First library is OS, which is the standard operating system related function library of Python. These next two libraries, CV2 and matplotlib.pyplot. CV2 is an image processing library of Python. It is available in other languages also, and it is a very powerful image processing library with many functions dedicated specifically for image processing and image related operations. Matplotlib.pyplot is a visualization library, and this contains the functions to help us visualize and display images and plots in our notebooks and in our terminals. Now, during your study of machine learning and data science, you'll have to understand and work with lots and lots of libraries. And reading all of them and knowing every single function of every single library is kind of an impossible task. So what I would suggest is that you understand what these libraries are about and you understand how to get help in those libraries. So suppose that if you want to do something, you should guys should be able to know what to search in order to get the function of that particular library. In order to do that, you need to explore the manuals of those libraries. So this will be an important task, and in fact, this is the assignment for today's session. That we will give you some libraries, and we would recommend you to go and explore the documentation of it. I don't want you to know all the functions. I just want you to know what that library does and where to get help in that library. And suppose if you're stuck, what function that you need to use or how you can understand about what that function does. So all these details will be in the library documentation, which is also called docs. And I want you to know where you can search for the docs and how you can operate the docs. So here, the first thing that we need to do is we need to provide, okay, where is the data located in our system? So this is provided in the data path, which is in content/balanced data, because when we extracted the extracted data was placed in a folder called balanced data. Now after this, we are creating the first function called display image. Now inside this, it is doing two things. Number one, it is taking a label from the labels file with image name and image label. It is creating a complete absolute path of that image, and then it is reading that image, and after this it is using the matplotlib library to show the image. Similarly, get image function, this is also reading the image, but instead of displaying the image, it is returning that image to us. Now execute this cell, Ravi. So now we have these two functions. Let's check them. So the first thing we are going to do is we are going to display an image called 586. So Ravi, please go and display an image. Display image, just run the cell. Now I want to change the number of this image and start, let's say 225. Display image 225. Just change the parameter of that image. Now what this is doing is it is taking first the number 225 and then it is going to the labels data frame and finding out the name of this image and then the label of this image. After this, it is going to the display image function. Inside that, first thing what we are doing is we are concatenating the path where this image is located along with the extension. Then we are reading this image and then we are displaying this image. Now let's this is just one image, so let's look at some more images in detail, and this time we want our images to be in random. So here again we are importing another library called numpy. Now numpy is a very important library because it contains mathematical functions. NumPy stands for numerical Python, and it contains mathematical and linear algebra functions for Python. And since our work will is too much on the mathematical side, and there are lots and lots of computations involved, this library will come very very handy when you are experimenting with your own algorithms and when you are developing your own algorithm. So keep an eye out for NumPy and try to explore as much as possible of this library. So here, what we are doing is we are taking the numbers in the labels. So suppose that the labels contain 750 elements. So what we are doing is we are taking numbers from 0 to 749 and we are shuffling them up. And then we are creating another array which for each index it contains a number between 0 and 749 but in randomly shuffled order. So go ahead and shuffle that image. So shuffle the image library. There was Now here, what we are going to do is we are going to visualize the images. So first thing that we are going to do is we're going to create a plot of 16 by 16 figures. So we are going to use the plt.figure function of matplotlib. And what it is doing is it is creating 16 by 16 grid of images. So it will create one single image. That image will contain 64 images in 16 by 16 grid. Just scroll up to scroll up. Now after this, what we are doing is that for now this grid is ranged from one from left to right. So the leftmost top left image, that's image number one. The next to it is image number 2, 3, 4, 5, and so on and so forth. This way, we can display 64 images. So here, what we are doing is for I in range 1 to 65, we are reading an image from the shuffled order, which is a randomly distributed order. And then we are plotting that image, and then we are plotting this entire grid. So inside this, scroll down a little bit. Yes, just enough. So as you can see, this is the images that we will be working with. And here, I don't know whether you can see the problem or not, but the images, they are not in a uniform shape and they're also not in a uniform order. There are some images which are a complete circle, some images which are cropped from the top, some images which are cropped from the left. Some images have very sharp boundaries, some images have very dull boundaries. Even the color of these images vary a lot. And the position of the iris, that little circle on the dot, that also is different in every spot. So you can see that we are dealing with a very non-uniform data. Okay, I just got a question from Pujita. Now here, your problem is that you have not executed the cell before it. So the cell with which creates the label data frame, that cell is not present in that cell has not been executed. So execute that cell, and then when you come to display images, it will work. Now So you can see here we are dealing with a wide variety of images and with wide variety of distributions. But actually, what is a computer image? Like when we see a orange ball in the middle of a black space. But how does a computer see an image? So for this, we need to extract a single image and dive deep into that single image so that we understand what an image is made of. So Ravi, if you could scroll down a little bit. Okay, now digital images. Now there is a difference between how we see a computer image and how a computer sees it. Now for a computer, now Ravi, slide a little up. Just slide a little up. Okay, no. The first cell after digital images. Mm, Go on to the next cell. The digital image, yes. Run that cell. The first cell after digital image. In check image in detail, yes. So here you can see that when we extract an image from the labels.ilog file, which is suppose that here we are extracting the image number 45. Now this image number 45 gives us a code of that image and a label associated with it. So the code is this one eight something something something, and the label is zero, I guess. Now after this, execute the next part, next set. Now here, what we have done is we have joined the data path with image name plus the extension, which is .png. So the output is content.balance data dot this. Now after this, we are execute the next cell. Now here, this is what a computer sees in an image. Just excuse me for 2 minutes. Am I audible? Ravi, am I audible?
Yeah, yeah, you are.
So as you can see, for us, an image is a beautiful picture with beautiful shapes and colors. But for computer, this is just numbers. Now let's understand what these numbers are made of. So every time you see, let's imagine that you have this computer screen. Now the part in this computer screen on the top left corner where it is activities. Ravi, can you highlight that corner, please? The top left corner of exactly where your screen on the left side, the leftmost edge of your top of the screen. Yes, scroll a little bit down. Now this point, go a little bit up exactly to the edge of the screen. Yes. Now this corner, this particular corner, this is the origin point of any computer screens. Now from here, when you go left to right, your x-axis increases. So imagine this like a coordinate system of x by y dimensions. The x dimension goes in the left to right direction, and the y dimension goes in the top to bottom direction. So so for computers, each image is a multi-dimensional array of integers. And what it does is that suppose that this particular section is comprised of 1368 by 720 or 1920 something by 2080 pixels. The shape, which we call resolution, that is actually the number of pixels in the x direction and the number of pixels in the y direction. So in total, you get x by y pixels. What is a pixel? So pixel is basically the smallest dot in your screen, which can be displayed in a particular color. So all the colors that you see. is this is just a bunch of pixels showing a particular color. So you're the part of screen which you see in red color, you're seeing in red color because it is being displayed in red. The part of screen which you are seeing in green color, it is because the pixel there display the color in green. Now, if we wanted to store this image in digital form, all we need to do is maintain the ratio or the grid, which is the spec of the image, and also the value that okay, the pixel number 1 and 2, which is 1 in x direction and 2 in y direction, has this particular value. So here you can see that the image color has been reversed. So what we are just doing is image. Am I audible? Can you guys hear me? Is my voice audible now? Okay. Now, Ravi, if you can scroll down. Okay. Now, execute this cell, which type image, length image, and image dot shape. Now, here, as you can see, that the image is 1536 by 2040. So, what does this means is that in this image, there are 1536 by 2048, which is 3,14,500 and sorry, 31,45,728 pixels. Each pixel contains three values, which are called B, G, and R. Now, B stands for the blue component value, G stands for the green component value, and the R stands for the red component value. And as you know from our basic chemistry class, if you mix three colors, or basic physics class, if you wish, if you mix three colors of red, green, blue, and green in a certain ratio, you can get any color of the world. And this is what is happening here. So the red, green, and blue, they mix together to give you a particular color of that direction. Now, here it is BG and R because remember that we use the OpenCV library, and the OpenCV library reads image in BG and R order. Other libraries, they read image in RGB order. Now, this has nothing to do with the image quality or the library quality. It's just that the layers are reversed. But if you're not careful and you try to pass image read by OpenCV to another library without swapping the order back, this will give you a problematic image. So here, what we are just doing is uh, execute the cell plt.imshow. Now here, as you can see, the image color has been reversed because now the red component gives the value for the blue component and the blue component gives the value for the red component. So as you can see, the images are, the color are actually inverted. Green remains green, so no swapping there. And since black is an addition of red, blue, and green, so the black does not affect after all. So what we can do is we can just simply swap the layers back. you can see that in the second cell plt.im show with cv2 dot convert color. Ravi, execute this cell.
Hello, Shubham. I think we have a doubt in our chat.
Okay, image data. No, we cannot say that it is a structured data because see, when we say an image, that image is stored in a matrix in computers. It's just that we don't see that matrix, but computers store them in the same way. What you are looking here, this is stored in a computer in that matrix format always, and it is unstructured only. It is still not structured. Now let's examine one single pixel of this. Now see, when I said that okay, this every pixel has three values, each of these values represents a color. So this is why when we say RG and B, we say that there are three channels. So there are one channel for red, one channel for blue, and one channel for green. Now, if you want to understand this image in a matrix notation, imagine three matrices, each of a particular x by y space. So in this case, our x is 1536. Sorry, our x is 2048, and our y is 1536. So here, this image is of 1536 by 2048 scale. And inside this, every single image has three values, a red value, a blue value, a green value. So this is three channel images. If you have a black and white image, it will have just one channel with the value of gray or with the value in gray scale. So it will have just one value. So let's go and examine a single pixel ahead. So Ravi, execute the next cell, print img value of this. Now here, what this is giving you is giving you the value of a single cell. Now since the image that we have stored is still in BGR, 15 is the value of the blue component, 95 is the value of green component, and 160 is the value of the red component. Now let's do something. Let's create our own image and see how that goes. So for that part, what we are going to do is we are going to create a random array of the same ratio. Let's say 1536 by 2048. And since we want this to be in an RGB channel, we are giving it 1536 by 2048 by 3. This is the dimension that we are giving. So here we are using this NumPy library called numpy.random.rand. And numpy.random.rand, what this will do is it will take a dimension tuple from you and it will return a array of random numbers between 0 and 1 of that dimension. So go ahead and execute this cell. Now here rand image is just a NumPy array. Every value of this NumPy array is a three tuple, and each of the values inside this three tuple contains a value between 0 and 1, and it is a floating point value. Now remember, we need to have a value between 1 and 256. If we assume that okay, we are going in the intensity of 1 to 256. So what we are going to do is, first things first, we are going to okay, first things first, we are going to create a random array which we have done. After this, my voice is still audible, right, Ravi?
Yeah, yeah.
Okay. After this, we are going to scale this number from 0 to 1 to 0 to 256. And the way we do it is by multiplying 256 to the random image. Now, when you multiply an array with the scalar, it gets multiplied to all the values inside that array. After this, when we print it, you can see that, okay, the values are in 0 to 256 range, but they are still floating point numbers. We need integers. So then we convert this array into an array of integers and then we print the value. So now we have an array value of the pixels. Run this cell, Ravi. So now here we have this array value of 48, 144, and 112. Okay, now let's go and check the type, length, and image shape. Oh, yeah, go ahead and execute this cell. Yes. Print type random image, length random image. This one. Okay, now if you scroll up and you see when we checked the image shape, go ahead, keep scrolling up. Here. Mhm. Now here, if you see that here we check the shape, the type, and the length of the image. Now here, this is exactly what we just created randomly using NumPy. So there is technically there is no difference between this array and that array. So now you know that a NumPy array and image, digital image, they are the same thing. Now scroll down, Ravi. Now inside this, now what we are going to do is we are going to use the matplotlib library to display this random image. Go ahead, execute the last cell. Now here you can see that since all the numbers that we have, they are in the same probabilistic range. Everything was between 0 and 1. We scaled it to 0 to 256, so this scaling was also uniform. And then the three channels also, they have uniform data. So when you sum all this together, you kind of get this grayish, noisy background. And this is the image that we have just generated. This does not have any kind of pattern inside it because the data is completely uniform. So this is why you get this zigzag screen. Now, what I want you guys to do is, I want you guys to explore images and what kind of operations we can do on images. This is very, very important because every image is a numeric array, and what you can do on an array, you can do on an image, and vice versa. What you can do on image, you can do it also on an array. Now, what I want you guys to do is explore images using NumPy, OpenCV, and Matplotlib. Now, inside this, Ravi, if you can just open the OpenCV link in a new tab. Now here, go on image processing in OpenCV. Sorry, go on code operations. Now go on basic operation on images. So here you can see that there are multiple types of operations on OpenCV. So this is where I want you guys to start and explore this library. I don't want you guys to be an expert in OpenCV overnight. I just want to get a basic feel of it. And perform a few basic functions of OpenCV so that you can get your head around it. Go back to the notebook. Okay, I want you guys to do the same thing for NumPy and Matplotlib. In our next session, we will start with building data pipelines, and we'll start with the component of taking a data pipeline and connecting it to a neural network, and then training that neural network together. After this, the next session, you will understand about convolutional neural networks and what convolutional operation does. Till then, I really want you guys to explore this library because next from the next sessions, these assignments will be of coding nature, and you'll have to perform some experiments on this data set to complete that assignment. So this is why I want you guys to be familiar with NumPy, OpenCV, and Matplotlib. It's okay if you want to go back to the tutorials or go back to the manuals and check when you are doing the assignment. That's all right. You can always take help of this assignment. But I really want you guys to understand how these libraries work and what these libraries are doing. Because suppose that if you didn't know that, okay, OpenCV reads images in BG and R, you couldn't possibly know why the image was displayed in blue color instead of being in orange red. If you guys have any questions, you can share it with Ravi. We'll sort it out. So your assignment for this session will be to explore NumPy, OpenCV, and Matplotlib. Get your hands dirty with some of the basic functions and experiment with the dataset. You have the dataset, you know how this has been explored. So go on, try some few basic operations on images, try to add two images, see what happens, so on and so forth. This way, you'll have this data under your fingertips so that when we start with some image manipulation for our network, you know exactly what's going on. If you have any questions, you can ask them. If you have any questions, you can ask now, or you can just message it in the message box. Okay, friends. So this brings an end to our today's session. I hope to see you guys on our next session, in which we will start with the convolutional operator and the convolutional neural network. But till then, please explore these libraries and please explore this data set. Okay, Ravi, we can end the session now.
Thank you. Thank you, Subha.